My pleasure. Krishna Vedula from IUC India here. Myself and Hans, we host these programs regularly. It's real pleasure to have our global presentation today. One presenter from France, another person from Nigeria. And the topic for today's webinar is enhancing teaching with the help of simulation, bridging the lab equipment gap. That's the subtitle of the talk. And so we are delighted to have with us, we have Professor Olayinka Adewunmi. I don't know if I got it right, but she is the Director of Innovation Technology Management Office in the Department of Mechanical Engineering at the University of Lagos. And then we have Dr. Nicholas Martin, who is Manager in the Ansys Academic Program. And she's worked for many years in material science and engineering. And so the collaboration between industry and academia is the perfect example of how we should be moving forward. So thank you both for joining us, and over to you.
All right, great. Let me just put my screen here and we can get going. Okay, so we should be good to go. Yeah. Yeah, very good. Okay, so hello everyone. Good morning, good afternoon. Thank you for joining, and thank you, Hans, for giving the possibility for us to present here today with my co-partner in presentation, Professor Adewunmi. I'll also thank again the support from IFES, GDC, and IUC in running this webinar series and give us this opportunity. I'll dive directly into the agenda of what we will be both covering today. I'll be handling a bit about the introduction with regards to this project, and in particular talk a bit about the Ansys funded curriculum partnerships from which University of Lagos and our guest speaker here has benefited it from. And then quickly I'll hand over to Olayinka so she can actually dive into the curriculum changes that they have implemented in their different degrees. Very few words about myself. I'm, as mentioned, a master's in engineering by training. I did a PhD in the topic. I've been working for about 10 years in the academic space, where I've developed expertise in material selection, eco-design, and sustainable development, mostly around engineering and design in education. I'm part of Ansys, and in particular, the Ansys academic program. And if I want to keep it short, the three main activities I'm involved into there are the support of academic usage of Ansys tools and technology, the creation of resources to support engineering education, both learners and educators, and also having engagement and collaboration in engineering education through conferences, workshops, and lectures. I took out a couple of pictures here from two of the past World Engineering Education Forum that IFES organizes, to which I contributed to, so you might have bumped into me there. With regards to Ansys, for those who might not be much familiar with the company, Ansys is the leading engineering simulation software working on across many types of physics, from structures, fluids, electronics, optics, materials, and machine engineering, just to cite a few. It's a company that has about 6,000 employees nowadays, and the 2024 turnover was $2 billion US, roughly speaking, if you want to get a sense of scale of the company. Now, we have an academic program within the company, and this is where I am working in. The program has the mission that is mentioned here to really look at providing students, educators, and researchers, so the whole academic ecosystem, access to our industry-leading simulation software, and to help on the learning and education resources through the support of the usage of our tools in engineering, science, and design. Now, we work on our program through 5 areas or 5 approach, if you will. The first is open access of learning and education resources, and I'll have a chance to say a little bit more about that in a minute. We work also on having as much as possible friction-free software access, especially for learners at universities. We have a dedicated student product that is used in many areas. We put a lot of effort by supporting and providing expertise on curriculum embedment, and with today's talk, we'll get a chance to give a clear example of that type of work. We also a lot engaged with student teams, as they are a group of students which are highly passionate about engineering in general. So we provide as much support as possible to them to help them progress in their competition, and whenever possible make them win using some of Ansys tools. And finally, we also have dedicated actions with regards to the usage of our simulation tools in research through research partnerships or other types of engagement here. You can see here at the bottom a few numbers about our academic program here. The one that I'll highlight is the innovation courses. These are one example of the open learning and education resources we develop. It's actually going to be my one of the two items I highlight when it comes to resource development. So our innovation courses are online free physics engineering courses that spans a broad variety of topics: structural engineering, fluids engineering, electronics engineering. And it's addressed for either students or young professionals who want to upskill as a complementary way to support their learning, either on concepts and fundamentals in engineering and physics, or on applied topics. And those courses are typically a succession of short videos followed by either hands-on workshops and questionnaires, quizzes that they can do to check a bit the learning progress. This is actually supported by certification at the moment, so young professionals can also value this as part of their employability. The second sort of resources and open access resource I'll put forward here are the ones that are addressed for educators. So we have a dedicated platform for education resources, which spans from lecture units, case studies, exercises, tutorials, in order to support the teaching of either fundamental or applied topics. And educators can freely access those to pick and choose whatever content or whatever part of the resource they feel relevant to build their curriculum. This part is also important to highlight because it's strongly linked to our curriculum integration actions, and in particular the funded curriculum partnership program. So the funded curriculum partnerships, this is something that we have been running for a few years now at Ansys as part of our program. Academic institutions and professors are actually encouraged to apply to a call for proposal, in which they will come in and suggest some curriculum changes that they would like to get support financially for. Those changes should include, innovation in the teaching, and also a connection to the use of some of Ansys technology. So participants that are selected through the call have quite a number of benefits out of it. One is, of course, helping to increase the students' employability by including in-demand skills in their courses. They are also receiving support from our end with industry standard tools. We try to encourage as much as possible in the proposals, thinking about student engagement and retention. It's also here to increase the visibility of the people that do receive the funding, as we also make part of the requirements of the outcomes of the proposal. That people look to disseminate the education changes through engineering education conferences, such as the one supported by IFES. And finally, it's also another opportunity for people, for professors that receive the funding to share their work, because one of the other outcomes of the partnership is that they will be creating a resource to support their course evolution. And that resource will be made available to the community through our platform. So this program has been running since October 2022. We had received applications from over 29 countries. You can see here on the bottom left the distribution per country to which funding was allocated so far. We have 58 universities that have received funding so far. And they really span across many engineering disciplines, as you can see here. There is already about 30 new teaching resources that have been published as part of this program, and there's quite a number of projects which are at the moment ongoing. An example of such partnership I'm showing you here in summary. It's with the University of Newcastle in Australia. They were really trying to think about revamping their engineering curriculum across multiple departments a couple of years ago, with having in mind the will to better align their courses to industry demands and also prepare better their graduates for engineering careers. So they received $25,000 funding to support the development of 7 different courses, which are listed here. Those were the courses in the mechanical and mechatronics departments on aerospace system engineering department. And 32 resources were created out of this program. One important thing to highlight here with our funded curriculum partnerships is that we encourage as much as possible that the applying university proposes also matches funds. This is a way for us to make sure that there's also strong support from the local school or of engineering, or the heads, the direction of the school, to have curriculum evolution. With that, I'll close on my end by mentioning that there is actually a call open for the second half of the year. This call is open until the 26th of September. I will be passing in the chat the link to the webpage that provides all the details with regards to what are the criteria to apply and actually how to do so. So thank you very much, and I'll pass here to Professor Adewunmi to continue and talk about their experience of this project.
Thank you. Thank you so much, Nicholas. So I'll be sharing my slides now. Okay, let's give me 1 minute to get it up. Okay, my other device was thrown out of the meeting, so I'm trying to get back in. Okay. So I'll be sharing right now. I think it should be up now.
Yeah, we are good.
Okay, thank you. So I'll just pick up from where Nicholas stopped, just to share our story. I'll be sharing what led us to apply for the funded curriculum program, the grants, and how the team actually started using Ansys and why we're motivated to bring this to our curriculum. So I just wanted to share this. This was published in the University of Lagos social media handles, even though we've been working with Ansys for some time.
Location.
Oh, can you hear me? I was hearing like a feedback. Oh, sorry. I thought someone was saying something.
We can hear you. Yeah. There was, I think, someone who had not muted, but I think the person was muted now. Yeah,
okay.
Sorry
So
about that.
I think I need to share again. I thought some people were saying they couldn't hear me, so I had to go off.
No, we're all good. Thanks.
Okay. All right. Good. So let me do this again. Just give me a minute. Okay. Okay, so I was saying that this was shared on our university social media handles, and it got us a bit famous, even though we've been working with Ansys for a while, but it was just some small group of people within the faculty that knew that we're actually pushing to see that our students were using the software. But immediately the grant came, the whole university kind of were aware that there was something called the Ansys funded curriculum grant, and there were a group of people within the Faculty of Engineering trying to do some work in this area. But before that happened, our connection with Ansys actually began from the University of Pretoria. I did my PhD in the Department of Mechanical and Aeronautical Engineering at the University of Pretoria. I worked with Professor Meyer and Professor Tunde Bello Chende, and they wanted me to do my PhD using Ansys. I'd never used Ansys before. Before then, another team member, Dr. Olakoijo, was already on his PhD, but he used Gambit Fluent and actually incorporated a program that was put together at the University of Pretoria, Dynamic Q, for his PhD. And we also had Professor Adelaja on his postdoc within that period from 2018 to 2016. Within those 3 periods, 3 of us passed through the University of Pretoria in the same research group. And that was where we actually started using Ansys from. When we got back to our home country, still with that collaboration with University of Pretoria, University of Lagos became one of the universities that participated in the Royal Society grant. The student that came on the project at our university was using Ansys also. And with that grant, we're able to put together a small CFD lab. We're able to get some Ansys research licenses. With that, we're able to expand some of our efforts to some undergraduate and postgrad students, but only on the research level. We weren't incorporating it in our teaching at that time. And we only had a small group of people. So this is just a background of how we started using Ansys. But we were looking at how can we go down to first, second year students so that they can begin to use the software, because for research, it was a bit tedious for us. We had students already in their final year doing projects. They had no simulation skill. They had no understanding of how they could start using it. And they were almost out of the university. We also had postgrad students that had gone through their bachelor's program without any form of experience with simulation. So we felt that it was already a bit late at that level, and we're looking for opportunities. But why did we actually want to have simulation incorporated within our teaching and learning within the University of Lagos? One, we had no structure for teaching simulation to both undergrad and postgrad students. Students only had opportunity to use the simulation software in their final year for projects. For us, it was the impact was low, and it seemed to be a bit too late because they are almost out of the university. So students, and also it was only students that their project supervisors were interested in simulation that were making use of the lab. And we were looking at least having almost every student within the faculty have, even if it's a bit of interaction with a simulation software. What were the opportunities? Those were the challenges. The opportunities was that for myself, Professor Adelaja, Dr. Lakoijo, we've been teaching courses in fundamentals of fluid mechanics, thermodynamics, heat transfer to students over the years. So it wasn't that it was new to us. So we had students pass through us from their third year to from their second year to their third year to their fourth year to their final year, but we didn't have that structure to be able to introduce simulation into our courses. Also, another opportunity was that, of course, other higher undergraduate level courses also were being taught by Professor Adelaja and Dr. Lakoijo, members of the team. I also had been teaching incompressible fluid dynamics at third year for a very long time. So even though we had challenges, we actually saw that we had very good opportunities to bring this to the university. Also, the three of us were on the MIT Empowering the Teachers Fellowship at different cohorts. I was there for 4 months in 2019. Dr. Lakoijo, a team member, was there 2016. Professor Adelaja was there 2014. And that program got us to think around our curriculum. And as part of what we're supposed to take back to our home institution, we were supposed to look at the Bloom's taxonomy and ensure that our students get to the level where they can create, not just regurgitating what they have been taught, not just understanding or applying concepts, but they were supposed to be able to create something so that they could be problem solvers and possibly job creators by the time they go out of the university. And we're supposed to come up with one course that we teach and actually show the changes we're hoping to make when we get back to our home university. So this was my fluid mechanics course that I chose during that program. And what you can see highlighted was what I actually wanted to introduce as part of the curriculum when teaching this course. And this actually gave me a structure that when I get the opportunity, I was going to, introduce this. Also, the other two team members had a course in thermodynamics, heat transfer, that they already designed during the MITTT program. So when the opportunity came for the funded curriculum grants, we already had a form of structure we had designed over the years, just waiting somewhere for us to implement. And it was with that structure that we applied for the grant. So the grant needed us to state which courses, how we're going to introduce Ansys, and what the funding we go into. And these were the 3 courses that we actually selected because we already had a prepared structure. For the fundamentals of thermodynamics, we have 6 departments that take this course and 600 students that we could impact. Or mechanical engineering, we have a department, not even within engineering, within environmental sciences that was taking this course. So we could also expand that impact to another faculty. The fluid mechanics course, we had 2 departments not taking the fluid mechanics course. We had 2 new departments come on board, electrical electronics engineering and computer engineering, which means that we could expand our impact to 8 departments that could take this course. Then for the heat transfer, heat and mass transfer course, we had about 80 students. So it means at the total, we could actually impact about 800 students using the funded curriculum grants. Now, how, even though we had the grants, by the time we wanted to start executing, some challenges started to show up. One, of course, there were no laboratory sessions for thermodynamics, turbo machinery, and heat transfer, even experimental. We don't have a structured lab session. So what it means is that we can begin to develop some virtual laboratory sessions with Ansys. The laboratory sessions that we had for fluid mechanics was not integrated with the course. So you could just imagine if I'm teaching an introduction to fluid properties, I'm introducing the students to things like fluid statics. The laboratory sessions were maybe on things like buoyancy and stability. It did not actually connect with the classroom sessions that we're having with the students in a structured manner. Also, we have 600 to 800 students. We don't have that infrastructure to serve experimental laboratory to serve 600 students. And aside from that, with the funded curriculum grant, we found out that 50% of the second year students that we wanted to in part, didn't have personal computers. We actually assumed that all students coming into engineering programs, one of the tools that they should have is a computer. But we discovered that we have students from low-income families that couldn't even afford a laptop. The computational the lab that we had was grossly sufficient. First of all, it wasn't really updated. It couldn't actually, the RAM and the memory could not even, we could not even do what we wanted to do. So we had a grossly insufficient computational structure within the faculty. Also, the lecture timetable was overloaded already. So how do we have extra physical sessions with students that already trying to grapple with their timetable and the time that they had for their studies? So these were new challenges that showed up for us even after getting the grant. So we needed new strategies. First of all, to get the students interested in a new learning experience is something they've not done before, without them being overburdened with lectures and with courses that were already ongoing. So we decided to come up with this strategy. First of all, we are going to have our engagement with the students as tutorial sessions. First of all, to just introduce them to simulation and let them know how this is important to them and the skills they will gain from having. So we started with a form of webinar, introducing them to Ansys, demonstrating some of the projects that have been done using Ansys, and that drew the students in. Also, we had to come up with tutorial materials that we start with them from a basic level. So we had 4 tutorial sessions within a semester of about 12 weeks. So that is like a tutorial session for each month. And we now give them tasks to do that they had to submit. For the second year, we had 4 sessions. For the 4th year students, we have 5 sessions with them. We also needed to start with them slowly so that we don't scare them away. We knew and we also know that we could introduce them to materials available on the Ansys website, but we needed to draw them in first of all, to connect them with textbook questions that we give in class and turn those questions to simulation problems. And we actually developed tutorial guides with that. And we also had feedback forms. We hadn't done this before. The students haven't had this kind of engagement before. So we are both learning on the go. So we were actually getting feedback. We had forms designed to ask the students what their experiences were. And their feedback to us, we know it was like a dynamic thing. The next engagement, we had to take into consideration the previous feedback they had given to us. The sessions were structured, they were integrated with the course outline. So if we teach something in class, we had a tutorial session with the Ansys simulation software that showed them how they could actually use this concept in their design. This is a sample course schedule. This is for the 4th year. As you can see, when we first of all had a lecture on introduction to the modes of heat transfer. Immediately after that, we had a seminar to introduce them to what we're going to be doing with Ansys, to get them interested so that we don't lose them. Then we taught heat conduction, steady state. We now had an Ansys tutorial session that we turned a textbook question on steady state heat conduction to a simulation problem. And we walked them through that problem during the tutorial session. It was a virtual session, so we recorded it. So for those of them that maybe couldn't really get the concept, or possibly internet connectivity was throwing them in and out of the meeting, they could listen to the recording and work on the task that we were given. And we followed on with convection, heat transfer, and we just designed the schedule in such a way that Ansys simulation was well integrated into their learning. This is a textbook problem that we turned into a simulation problem for the year 2 students to introduce them to this is the mixing tank, a simple problem. Of course, this kind of problem they could actually solve analytically, but we also wanted them to see how they could go through using the Ansys design modeler or space claim, and how they could do the meshing, how they could set up the physics and all that using a very simple problem. So we didn't start with a complex problem. These are some of the results. We showed them how they could visualize, and this actually caught the attention of the students. So they could actually look at temperature changes, they could look at temperature distribution, they could look at velocity distributions, they could look at pressure changes. So it was, this engagement actually brought the course to life. It brought it alive for them. They could actually see the concepts we were teaching, and they could actually change some parameters and see how that influences, those the flow that was going on. This was another one, flow in a circular tube. In this case, we're trying to teach them changes in properties also leads to changes in the way heat, temperature distribution, velocity distribution happens. And this could be influenced by things like density, specific heat capacity, thermal conductivity, viscosity. So these are things that we're teaching second-year students, and it was their first year in the Faculty of Engineering, because their first year is usually in the sciences. And these are the kind of results that we said that they were supposed to get using the tutorial guides that we developed for them. They were also supposed to bring about a plot that shows how, as you go along a tube, how the temperature changes, what were the differences. You are working with different types of fluids. And it was really exciting. This was another guide we developed for the second-year students, because we teach also things like flow measuring devices. One of it is a venturimeter. So they could put this in the car. They can actually design their own laboratory, even if these equipments are not available within the lab. You can actually design your own lab, put in your parameters using the simulation software, look at how the flow happens. And we use this particular tutorial guide to actually teach them how to animate. This actually added to their interest in learning about the simulation software more. So it got them pretty excited, and we were able to draw them in. This is just a page of one of the tutorial guides we developed. So it's a guide that takes them through how do you create your geometry, where do you go to. We set this up for them so that they could easily follow during the tutorial sessions, and they could walk step by step with us. This is a sample feedback. So we designed the feedback form using questions to just know what their learning experiences were like. One of such questions, as you can see over here, was just to ask them, how did you find the webinar? This was before we started engaging them with those tutorial tasks. You could see that some of the students said a bit confusing. We're looking at, okay, what were the numbers? We also asked them what else. You see some of them saying, this is new to me. I've not yet grasped anything. So we go back again to the drawing board to see how we could help students understand. Some said, oh, I understand, but even as we go further. So this was when we did the webinar. We hadn't started the engagement. During the engagement, we actually also collected more feedbacks from the students that you can see. Some of them said, oh, I wish I had practiced before coming to the tutorial session. Some said it was easy for me to follow because I was able to do the first task. Some said that the time we were spending with them was too short. So this kind of feedback helped us to design better engagements with the students. Now, another interesting thing we did was that for the fourth-year students, they only had a semester. We didn't want them to just go in their second semester. The second semester at the University of Lagos for engineering students is for internship. They are supposed to go into industry for 6 months and do an internship. So we decided to put forward this challenge to the fourth-year students. This was voluntary. Or would you want to participate in a simulation challenge, look for a problem in industry, turn it to a simulation challenge, and you will win some cash awards. And these cash awards were coming from the grants. Because part of the things we said we're going to do was that we're going to put up competitions for students to use Ansys to solve a problem. Some of the student teams that competed, we reached out to Ansys, and as we're going along this, we're having check-in from the Ansys academic team. They didn't just leave us alone, trying to know what were the difficulties, what were the challenges that we're encountering, and they offered a lot of help to us as we're going along the way. We actually requested for Ansys to allow those on the teams for the simulation challenge to actually pass through some certification courses so that they could actually do more with what we've asked them to do. So this is a particular student. He was able to get 8 certifications. I think this in a period of 1 month. So he had 2 professional certifications and 6 associate certifications that went beyond even the tools we used. We used Fluent to engage with them and the steady state TAML. They went as far as going to the structural stress analysis, the Ansys mechanical, and all that in their engagement. For those that participated, these are some of the problems they got in industry. We had a team that was looking at the exhaust within a particular automobile industry. It looked at this problem. It designed something that had to improve the exhaust performance, and it used the tools in Ansys. Some of them, not only what we used with them. We also had this team here. I'm just going to play this. This particular team here had a low simulation of a floating solar base to supply sustainable. So this particular team actually saw a community that didn't have electricity, and they wanted to come up with what they called a floater voltaics, where they could actually put solar panels to float on water and serve that community that was close to an area whereby it's a poor community. They had a lot of water, they had no electricity. So they were looking at how do they deploy floaters that could hold panels. So they shared with us the video of what gave birth to the problem they were working on and the kind of tools that they have. Another team that worked on radiators that were giving problem. They encountered like a Volkswagen transporter with a 2-pass radiator overheating, and we're looking at how to solve that problem. We had another team that saw a problem with a pump that kept breaking down, costing the company some money. Those were some of the problems. We had 6 teams overall that worked on this problem. This here is a workshop and training we had this year, last month to be specific. The teams that worked on this problem, we had our engagement with them last year. We put forward another training for the new set of second-year students that we're going to be engaging during the semester. And the interesting thing is that we decided to step back as facilitators. 2 of the students that were trained and went through our first engagement with incorporating Ansys with our curriculum actually facilitated the training that we had last month. These 2 students were part of those that got the certification. And this is just a video showing the students seated in this class are currently in second year. We are just starting to engage them. So we are still, following up on what we've built on using the funded grants. So the students working with this second-year student is actually now in final year, but he was the one that facilitated the training along with one of his colleagues. This is just a picture of the training with the students. This is my colleague, Dr. Lakwejo. This is the final year students that served as a facilitator. These are second year students. This Dr. Lakwejo and myself. just addressing the students, sharing with them. These are the students that participated in the simulation challenge. We awarded them certificates. All the teams got some cash awards. Of course, we're really impressed with the projects they worked on. So these are just pictures. This is just from last month, what we're still doing with the students. So for the future, in collaboration with the Ansys academic team, we want to continue to build on what we've done. So in the next 3 years, we're already looking at getting 250 teaching licenses. Because of what we achieved with the students, we approached a particular network within our university that had some funds. So they will be funding us for the teaching licenses. Also, because of the impact of the work, Ansys also supported us with some discounts to get these teaching licenses. We'll also be coming up with new student projects for the CFD simulation session. So what we're going to be doing now is that we're going to share with the second year students that are currently in their semester all the resources we had with the previous last year. Then we are going to be giving them new projects to work on, and that will keep building our resources for the students. We're also going to be working on expanding curriculum development to other courses within the faculty. We're also going to be developing courses that University of Lagos could offer to industry so that there will be sustainability of our getting the licenses funded. We're also going to be expanding participation to other faculty members. For now, the team is more CFD, fluid dynamics, e-transfer. We want to bring more of our colleagues in material science, structural mechanics, and electronics on board. So thank you for listening. Yeah, I think I said a lot. Thank you very much for listening.
Outstanding presentation, Professor Olayinka, and of course, Nicholas Martin. This is terrific. So we can open up the session for some question and answers. And if Nicholas, if you found something on the chat box that might be of interest to share, please do that. You can just wait while others put on the chat box, or just raise your hand and say, I want to talk. Okay. Whoever wants to talk, welcome to do that. You have 10, 15 minutes to do that. Okay, the question from Prashant Revankar. How do you integrate sustainability concepts in your curriculum in fluid mechanics?
Okay, can I go ahead and respond? Should I respond to the question?
Yeah, I think it's best for you. Yeah, it's for you.
Okay. Yeah. Okay. Okay, so for now, our curriculum for the second year students, we've not actually put in sustainability. What we just did was that our old curriculum that we had before, we integrated Ansys within it. So where we go to introduce sustainability is more in our projects, our final year projects. So I think this is one of the things that we will be doing with the Ansys academic team, to actually look at what we have right now and see how we can incorporate more concepts for the students. For example, sustainability as part of what we teach the students. So that has not been incorporated in our field mechanics course yet. But like we said, from now till 2028, we are going to be looking at this curriculum that we have, and we are going to be looking at introducing new concepts that we can teach in class.
Excellent. I was really impressed, Professor Olayinka, with the systematic approach that you took, starting from all the way from the lower levels of Bloom's taxonomy and taking the students now to start simulation and then beginning to create and then finally do some projects. And that was really an outstanding example of your understanding of teaching pedagogy and make sure the learning is happening. And I think that's very, very impressive.
Thank you.
Okay, I'm just those with my first IPS webinar experience. Thank you very much. Hope to see you soon. Thanks to Anja for joining us. I have a quick question while we wait for other chats. This may be more for Nicholas. I noticed in your presentation that you have 4 institutions from India, University of India, participating in your program. Can you share maybe who that might be, or do you know them? If not, maybe you can later on we can explore that part of it.
Yeah, so 4 exactly 4 from India. I'll need to look because on top of my head,
Sure.
I might get mixed up
problem.
between those who did apply and those who actually get funded. But I'm happy to share that.
No problem.
Yeah.
Because we work with 50 institutions all over India. So I was curious if any one of our guys was involved. Okay, Avinash Valmare has a question. How can we use it for HVAC and R course?
HVAC.
Yeah.
I think I have a response to that.
Yeah, go ahead,
for
please.
example, like I said, the funded curriculum program, we just introduced 3 courses. Some of the projects that the students did for the simulation challenge, where they got awards, were for HVAC industries. So a lot of the tools on Ansys, for example, HVAC has fluids. There it also has some heat transfer. So definitely HVAC courses can be introduced. We even have final year projects that are heating, ventilation, air conditioning, refrigeration based, that the students are using Ansys simulation software to actually look at that process. So there are tools in Ansys that can be used. It might not just have HVAC and R as a tool, but the processes, the physics of the problem determines the tool that one will use. So if you are looking at the fluid flow heat transfer, if you are looking at the energy efficiency, there is a tool in Ansys that could actually help with that. If you are looking at maybe the material selection for those processes, there's a tool in Ansys for that. So the physics of the problem actually determines the tool in Ansys that one can use. I don't know whether Nicholas has something more to say on that, to my experience.
No, that is completely correct. Yeah, that is completely correct. The thing that I'd add is that there is also a trend to find ways to support, especially in final year projects, possibilities to interconnect all the physics, because that's typically an environment where student project will be combining for specific application all that they have learned, which is not always an easy task. So on that, we on one hand, on the sort of technology side, or the different software are more and more integrated and interconnected. And on the sort of supporting resources side, we also try to develop teaching examples of resources that sort of showcase a little bit this sort of multi-component and multi-physics integration in design projects.
That's very good. So Olayinka, there is another question here from Prashant Revankar. Experimental validation of Ansys results to lab experiments can make the study enriching. So have you done any validation of some of the results that you obtained from Ansys to actual lab experiments?
Yes. I'll now focus on the projects that we do, because without validation, you can't even publish that work, because you should be sure that, because of course, we are using a simulation tool and you put in wrong parameters, you will definitely get results. The question is the result correct? So there are 2 approaches we use with our students. We have maybe 2 students working on a project. One is carrying out the experimental part of the project, while the other student is doing the numerical part of the project, so that there's a form of validation. The second approach that we use is that for you to validate and to be sure that you can actually use the simulation software, we tell you that there are published works experimental works that have been done. The first thing is for you to be able to demonstrate that you can recover the results of those experimental work using the Ansys simulation software. So the student takes that experimental work and puts in the model in Ansys, and we now compare the results obtained numerically with what was published experimentally. And that also takes them through the process of things like refining your grid to be sure that you have your, so they get more knowledge about the simulation process by doing the validation. So those are the two approaches we use. So we have students working collaboratively, experimental, numerical. Then we also have students that are doing numerical studies, but they need to validate what they are doing with some works that are already available in literature.
Excellent. That's very nicely done, explained, Professor Olayinka. Quick question that I have is, now that you have done a systematic approach to understanding the challenges and then overcoming them and step by step gone to higher and higher levels of understanding how to do all this part of the curriculum, have they, I noticed there are 50 participants here today, and many of them might be from, Nigeria, from other countries around where maybe these kinds of issues can also be addressed with the help of your experience. Are there other participants here today who might think that they might benefit from learning from what Professor Olayinka has presented, and maybe Professor Olayinka might already be collaborating with other institutions? Can you comment on that?
Okay. For me, I think we are open to, some colleagues have reached out to me from Nigeria. Like I said, we had our strength from University of Pretoria. So we have some of our colleagues also that that are, that are still within that network that we also, sometimes when we are looking at, for example, the simulation challenge, the judges actually came from different parts of Africa. We had a colleague from South Africa in one of the institutions that judged the challenge. We had a colleague also from Nigeria, but is currently in the United States that we sent it to. So those are the form of collaboration. So we leverage on colleagues within the same simulation form of ecosystem to help us look at what the students are doing. And I actually saw that also, did we have a rubric? We do have a rubric. For the judging system, we actually set up a rubric to actually evaluate what the students are doing. For what we did, what we just wanted them to do was, what we took you through the tutorials, can you do it yourself? And we now allocated marks for each of those processes. Are you able to generate your own card? And we had a submission guide that we gave to them, and also how the marks were going to be allocated. And part of their feedback also we took into consideration while designing all these processes.
Wonderful, wonderful. Let me give Nicholas a chance to wrap up. Any final comments, and then Hans can close the webinar. Nicholas?
Yeah, sure. Well, I'll just again reiterate that the sort of partnership that has to come with University of Lagos, and especially Adewunmi, has been of high quality, and I think the way that she talked about engineering education today sort of reflects that. And yeah, I just encourage all of you to think of this. If you have some plans in terms of curriculum changes that you want to implement, we're happy to partner on this.
Great, thanks, Nicholas. Over to you, Hans.
Thank you very, very much, Krishna. Dear Nicholas, dear Olayinka, it's a real pleasure to meet you, to connect with you. I'm very deeply impressed And I think all of us participating is a wonderful participation in terms of the presentation that you've made. And just want all of you to know, particularly there are some that are here for the first time, we have a recording of this this webinar that we share always very, very willingly. Just a couple of things that comes to mind, Krishna, just to listen to this thoughtfulness is, I'm so pleased that Ansys is an important member of our community, is sharing with us this important work that they're doing. And I hope we can build on that. One of the things, just to share with you, Olayinka particularly, I work closely, very closely, as a matter of fact, weekly, with a group of about 40 to 50 leaders in Africa, and that are writing 2 books. These are engineered from Nigeria, for example. I'm sure several people you know, like Tristan Bolu, Funso Falade, I can go down the list. In South Africa, several of the universities you mentioned are not only colleagues, also close friends, where we work very, very closely. And the fact that what you're doing is to encourage students in the way that you're doing is just quite inspiring. And let me link my comments then. I'm working as co-chair and with our global annual conference this year in September in South Korea. I was just there a few weeks ago as co-chair. They're working with, and a key, obviously, besides professors and corporate colleagues and deans of engineering, is the engagement of students. And obviously, that's always an issue in terms of the financial capability, for example, to come as far from Africa, you know, to that special part of the world, per se. I just wanted to let you know I'm very happy to share some information, and to see your creative engagement of students is inspiring, by the way. So, you know, Krishna and I have been facilitating the space here for quite some time, and to see this presentation makes me genuinely very, very happy. Thank you kindly, all of you, and particularly some of the new colleagues that have joined us here. One of the other colleagues that joined us for the first time is the new representative of Phoenix in Germany, which are my own roots and so forth, that joined us in here. And I'm sure she was also quite inspired. So Krishna, dear friends, colleagues, Olayinka and Nicholas, fabulous presentation. Peace be with all of you. Okay.
Okay.
Thank you
Good
so
night,
much.
good morning.
Thank you.
Goodbye,
Thank you.
everybody.
Thank you.
Thank you all.
Thank you so
Thank you,
much,
everyone.
everyone.
Bye.
Thank you,
Bye-bye.
everyone.
Bye-bye.
Thank you
you.
very much. Bye-bye.
Bye-bye.
Thank you.
Bye-bye. Bye-bye.
Bye-bye.